Hello everybody and welcome back, and in this tutorial right now what we are going to do is we will code our own small sniffer, which is actually going to be a little bit more advanced sniffer since we are going to use some libraries and some protocols that we haven't encountered before. For example, what we will try to do is we will try to sniff for the MAC addresses over our networking interface, and we will try to actually put them down in bytes and see what we get from them. So what we want to do is basically code a simple Wireshark-like program which will allow us to see from which MAC address are we receiving packets from and to which MAC address are we sending the packets to. So let's see how we can do that. Now, if you're an absolute beginner, this might be a little bit hard for you, but I will make sure to explain everything the best I can. And if you really don't get it, you can always go to the next lectures and get back to this one once you think you are ready and once you think you will be able to fully understand it. Now, even though this is a little bit harder than the previous programs, this is still nothing really special, as it will be a rather short program that will only print out the MAC addresses that we are receiving the packets from. And let us see how we can actually do that. We also want to print out next to the MAC addresses. We will, for example, print out the protocol over which they are communicating. So let's see how we can do that. Let me just zoom this in so you can see everything well enough. Let us go to our Python programs directory and let us go to our local network programs. So this is a program that will actually only work on your local machine. It doesn't have anything to do with the actual other machines on the network. This is just something you can run on your own PC if you want to, for example, test out your knowledge while coding, or if you want to simply just see the MAC addresses that the packets are coming from. Now, this can be useful if you want to, for example, detect the ARP spoofing or something like that. You can add a little bit of code to this program that we're going to make and make it an ARP spoof detector. But for now on, we just want to introduce ourselves a little bit more to certain libraries in Python. And we will make this program called, for example, macsniffer.py. And let's add our user bin Python. So user/bin/python to our program. And there are two libraries, or pardon me, three libraries, but one is not really necessary, so we can just remove it. We want to actually import the socket library and the struct library. So import socket. Now, this library allows us to actually communicate over the internet. It will create a socket object on our PC, for example, and then it will try to perform the connection to other PC. It is what is most likely used for once you import this library, but for now on, we'll do programs like that later on, but for now we just want to import it so we can use some of its functions in order to perform the task of our program. So import socket, and from struct, import everything. Now, what this struct library allows us to do is, for example, to import the strings as a binary, which allows us to actually manipulate the binary on a more deeper level. So I will show you what I mean. First of all, what we want to do is actually try to create a socket object, and then we'll print out the error in case that doesn't work. So let us see how we can do that. We can just use a simple try and except rule in order to perform the creation of the socket object, which we will just simply call s. So s equals socket.socket. And what we want to do is parse some of the arguments to this object, which will be the socket.af packet. Now, this socket.af packet is different than the socket.af_inet, which we will be using later on. Basically, the let me just show you. Socket.af_inet allows us to basically communicate using internet protocols, but socket.af_packet is something that we will use in case we, for example, want to manipulate the packets at a protocol level, which we actually want to do since we actually want to get the protocol from the sniffing itself. So let us see how we can do that. We specify the socket.af packet. We can put comma. We want to use the raw packet, so we can specify it with the sock_raw. And after that, we'll use a function which is called socket.ntohs. And in that function, pardon me, it's not comma, it is dot, so AOHS, open and close another bracket specifically for this function here. And what you want to specify in between the brackets is the number 0x003. Pardon me, there is one more 0, so 0x003, or 3 zeros and then 3. What basically this does is this function performs converting of positive integers from network to host byte order. And then after that we will import, as we imported the struct library, which will allow us, as I said, to convert strings to the binary, which we can then print out and get the full MAC address and the protocols that they are running on. So we made our socket object right here. These are the three things you need to specify. As I said, we are using the raw packet, we are using the AF_packet, since we want to actually manipulate the packets at the protocol level. And just in the except rule, we can just print out error on creating socket objects. So we can then close this, and we can actually exit the program as it didn't work. So once we actually make this, what we want to do next is actually enter the while loop, or while true loop, since we want to do this indefinitely until we actually want to stop it. So we will just enter the while true loop. We can do it like this. This will run forever as long as we don't stop the program. And what we want to do is actually receive the packet, or receive every packet from every port that we get. And from that packet, what we want to extract is the source MAC address and the destination MAC address and the protocol field. So if I just show you, let me just go right here and open Scapy, which we are already introduced with. I will show you where we can get the source MAC address and the destination MAC address and also the protocol number. So let me just show you right here. It is the packet called ether. So if you just type here ls and then ether in the brackets, you can see that this packet right here actually has three fields, which is the destination, the source, and the type. This type right here is actually referring to the type of the packet, which will then be stored in the binary right here, and the source and destination is the, as it says right here, the destination MAC field from to where the packet is going to, and the source MAC field from who the packet was sent from. So this is the packet that we want to interact with, since all these three things that we have are actually in this packet right here as three different fields, and we want to actually divide them by those three fields and extract all these three things. So let's see how we can do that. Let me just exit the Scapy, go back to my macsniffer.py. So we enter the while true loop, and all we want to do is just print the packet equals, and then socket object, which we created right here with the socket.socket, we want to actually receive from this object, or receive to this object from every port on our PC. Now there are, I believe, not really quite sure, either 65,535 ports or 65. We'll just go with 35, since that is the lower number. Now I always confuse these two numbers, so it doesn't even matter. We can just receive from this much ports. So packet equals receive from 65,535 ports. We want to receive the packets from those ports, and we want to store them in the packet variable. Now, since this is a while true loop, this will go, basically, first packet will go to this variable, then it will go back to the while true loop, then the second packet will go to this variable, and so on and so on. So what this while true loop will do is basically just receiving the packet. And what we want to do is, from that, we want to select the first part of the packet. So packet equals packet, and then we want to specify 0. We just select it right here. So packet 0. Since this is a tuple, we want to actually use the packet string from the tuple. Now, tuples are something I didn't explain, but if you're coming from Python, you basically know what that is. The next thing we want to select is the actual length of the Ethernet header. Now, the Ethernet header is basically something that I showed you previously in the Scapy when I opened Scapy. So we know that it has three fields: the destination, the source, and the type of the packet that we are receiving. Now, I can't tell you that the actual length of the Ethernet header is the 14 bytes, since the 6 bytes and 6 bytes are actually referring to, or first 12 bytes are referring to the destination and to the source MAC address, and the last 2 bytes are basically referring to the actual type of the protocol that the Ethernet packet has attached to it. So we can just select the Ethernet length to be equal to 14, since I just told you it has 14 bytes. The next thing we want to actually do is strip the packet to the Ethernet length, since this packet right here is not only containing the Ethernet header, it most likely, or not most likely, it definitely has other headers as well. For example, this could be something that we receive, for example, an ARP packet, so it will have ARP fields attached to this packet as well. So we want to strip everything from that. All we want to receive is actually the Ethernet header, and we can do that by just simply typing Ethernet header. So Ethernet_header will be equal to the packet. Then we open and close these square brackets. We add the 2 dots right here, and we type eth_length. Now, what this basically does is it strips the packet variable, which contains a bunch of other headers as well, from the beginning to the end of the Ethernet length. Now, we specify the Ethernet length to be 14, so you can actually just do simply like this. So you can just select here 14, which will select first 14 bytes, and right here, you basically did the same thing, but I prefer to do it this way, since then you know why I specified the number 14 here. So Ethernet_length. And right now we want to actually strip our Ethernet header from the MAC addresses and the type of protocol. Now, this is where the Struct library comes in help. We will use a function called unpack, so we will use a variable, for example, called ETH, stands for Ethernet, and we will equal that to the unpack. And in this function, we actually need to specify 2 things. We want to specify different way how we want to actually unpack it, which needs to be between the double quotes, or the single quotes, pardon me, and the packet that we actually want to unpack, which is Ethernet_header. Now, before I specify this part right here, let me just show you right here the Struct library table, basically, where we actually can see how we can unpack different types of packets. Since we know that our actual Ethernet packet has the 14 bytes, we actually want to separate it by first 6, then the next 6, and then after that we want to actually specify the last 2 bytes, which will be the type of the protocol the packet is having. So what we want to do is actually add this string right here. So we need to specify first of all the exclamation mark, so it knows that we are specifying this, then the 6s, and then the capital H, which will actually strip the first 14 bytes. And from these actual 14 bytes, we want to get the protocol after the MAC addresses. Let me just show you how we can do that. Basically, after this, all we need to specify is the ETH_protocol equals to the socket.ntohs, which is the function that we also used right here. And we want to specify right here, let me just show you, in the open and close brackets, the part from ETH, and then the third element, which we can actually select with the number 2, since, as I said before, the counting in Python starts from 0 and not from 2. As you can see, the third element will be the protocol, as we saw in this KP. Let me just show you once again. So KP, if I open it, and you basically ls the ether packet, or ether header, pardon me, you can see that the third field is the actual type, which is the type of protocol. This is labeled as 0 field, as first field, and as second field. That's why in the square brackets we specified it to be the number 2. So nano_max_sniffer.py. After that, we basically separate everything with the print statement, so we can print something like this. We open and close brackets. Let's print with the plus destination MAC, And then after that we can actually print, let me just do it like this, we can plus the Ethernet address, which will be the actual packet, the first 6 bytes of the packet. So we can specify that with this, so we can do something like this. So packet from the actual 0 to 6, since we know that the packet has 14, so we will split the first 6, then the second 6, and then after that we will split the protocol itself, but we don't really need to, since we actually selected it to be stored in this variable right here. So we selected the Ethernet address to be first 6 bytes, then we want to plus with the source MAC address, so source MAC will be equal to the basically the Ethernet underscore address, that's how we will call it, and in here we want to specify the packet, and then the second 6 bytes, which we can specify from 6 to 12 in these query brackets. What we want to do is close this. Okay, so we closed it. Now we have one bracket more. We forgot to close it right here, so let us close the bracket here. Here we have the brackets closed, and all we want to add is also the protocol, so plus, and then once again open the double quotes or single quotes, and then use the plus protocol, and then here we want to actually just add the string of this variable right here. Now, why we are using strings? Well, basically this is bytes, so we want to actually select this to be a string, otherwise we will get the error while actually printing this. So we want to actually just type plus the string from the ETH0 underscore protocol. Okay, so let me unzoom this so we can see everything well enough, and just close here another bracket, and that should be it. Now, this ETH0 is a function that we didn't code yet, so we need to code this in order for this print statement to actually work. This part right here will work since we actually stripped the protocol in the previous line, but this part right here we actually need to see how we can print the MAC addresses, since as we know, if I just go save this and just type ifconfig, you can see that the MAC address is split by these two dots, so we need to actually make a print statement that will actually take that in count. So we need to actually, first of all, nano the maxsniffer.py. Then here what we will do is we will add the function called def.eth underscore address, and we will parse the packet to it, and that packet we can just call A, doesn't even matter. You can call it anything you want, this is just the parameter for this function right here. As we can see, we are pasting or parsing to that function the packet first 6 bytes, and in the second line or in the second statement we are parsing the packet and then the second 6 bytes. So let's see what we can do with that. All we actually want to do is select some variable, for example called b, to be equal, and then in the double quotes we want to specify the actual printing of the MAC address, so we can print it like this with the, so let's do it something like this. So we can do the % and then dot to x, and then 2 dots, and then you can basically need to do this now 6 times, since we have 6 different fields in the MAC field separated by 2 dots. Now this part right here only represents the first 2 bytes of the MAC address, or pardon me, this X right here represents the hexadecimal, and this part right here only represents the first part of the MAC field separated by the 2 dots. So all we want to do is actually paste this 6 more times. So let me just add a space right here. We want to add a space, print once again, so print it basically 6 times since the MAC address has 6 fields. And then after we do this, well, we actually don't need the space, we can just do it like this. Let us remove the spaces and we will see how it works in the print statement, and then if it doesn't look really well we will just code it differently. And then this 2x right here basically represents the hexadecimal value, as I said, and we need to paste the parts of this A packet right here that we specify as a parameter to be put here instead of this % and then .2x. Now this is just some Python syntax, so don't worry, this isn't anything referring to these two libraries or the packet itself. This is just how we specify to print this MAC address right here. And basically what we need to paste between each of these percent signs is, first of all, let's add the percent. And all we want to do is add open and closed brackets and pass the ORD. And then in the brackets of the ORD function, we need to specify the A and then the first element for the first part of the MAC address. Now all we want to do is actually copy this. We want to copy it and we want to paste it 6 times, same as in the previous. Let me just add a space right here. So this is 4, this is 5, and this is 6. And all you have to do also is in these brackets add different numbers. So this will be 6th element, which we select by number 5, 4th element selected by number 3, or 5th element selected by number 3, 4th element selected by number 3, and then the 3rd element selected by number 2, and the 2nd element selected by number 1. We also need to specify the commas between all of these elements, so let me just add it right here. Comma here, comma here. So we actually code everything properly. All we have to do right now is return this string, so return B, to be actually printed out instead of this line right here and also instead of this line right here. And what this will do is actually print the MAC addresses from the packets that we are receiving from the Ethernet header. Now, this can be a little bit confusing part to you, but as I said, this is just similar to something like printing the print, and then in there you specify the actual percent %s for the string, and then you just specify in the percent, in the brackets, you specify some variable a, for example, and then this variable a will be printed instead of this %s. Just right here we don't have a string, we have hexadecimal, so we put basically %x, and then we parse this packet separated by 6 fields, since our MAC address has 6 fields separated by the 2 dots, and we paste them instead of this line right here. Then we return that line and it will be printed out right here and here also. So let me just delete this. Then we can save this program. So Ctrl O, Ctrl X to exit. Let's make it an executable. Now let's actually run it to see if it will work. And as we can see, this works properly. We got the destination MAC, which is the broadcast MAC address. We got the source MAC from this MAC of our router. Now I know that this is my router. And we also got the protocol, which is protocol 8, which I believe is the IP protocol. Not really sure. We can see we are receiving a bunch of those packets. So let me just fix some of these things, such as protocol needs to be specified correctly, and these 2 dots at the end really shouldn't be there. So let me just close this program, nano it once again, maxsniffer.py. What we need to specify is, first of all, protocol. We need to change this, and at the end right here, at the last hexadecimal statement, we do not need these 2 dots, since we are not actually adding anything to it anymore. And if I run this once again, let's see how it will look. We can see destination MAC address, source MAC address, and the protocol number. Now, in order, if you don't know what the protocol numbers are, basically if you just go and type protocol numbers, let me just go to some link which will, okay, so list of protocol numbers. Let's go right here. You can see the values of the protocol numbers. For example, let us see something that we are familiar with, such as the TCP. The TCP is selected as the 6, and you can go down here and have a bunch of the others protocol numbers as well. So you can check them out if you want to. Us specifying the actual string for every protocol would be too much of a work, so we just basically print out the number, which is easier. And right now we have our MAC sniffer, which will sniff the destination and the source MAC address, and also the protocol from which the packet is going through. So that would be about it for this video. I hope you enjoyed it, and we will continue coding in the next lecture. Hope I see you there, and take care. Bye.